So we have pulled the chassis out of this 65 Princeton here. Give you an idea of what's going on here. We've just got some age issues here, some design issues that we're going to take care of. The amp came into the shop with a really nice Mullard GZ34 in it, original one. One Zenith 6V6, which I believe is actually a GE. Looks like a GE gray plate. And over here we've got a black plate Sylvania. We've got a Sylvania 12AX7 and a GE 12AX7. This, guys, really, this is really a no-no. So anyway, let's see what we've got happening here. Get this back up here on the blocks. So we have a few things going on. Looks like our screen resistor here has been pretty hot. I'm going to probably lift this center tap here for the heaters. This in theory is a good idea, but if you'd happen to have a short from one of the screens or plates to the heater, it could take out your transformer. So I want to go back over here and put the 100 ohm resistors on here like Fender did, make a fake center tap. If you have a short, these things will fry. I've seen it happen a lot in Fenders, and it's a good safety factor. I like that. Something else we're going to talk about. I hear people biasing these amplifiers all the time, like 15, 16 milliamps. Fender sent these out of the factory, a lot of times running about 30. For some reason they seemed it necessary to push these amps into Class A, which actually is Class AB amp. But we will talk about the biasing a little bit later. But point here is 15 milliamps, way too low. You're going to have to find crossover in the amplifier. Another issue here with these is we have no grid stopper resistors on the output tubes. We're going to leave that alone because, oh my God, you don't want to affect the bloom of the amplifier for the vintage guys. Same goes with the screen resistors. So there's actually no screen current limiting on these amps. We also have a phase splitter issue. We'll talk about that more later. But these amps, this, like I say, is a regular Princeton. It's not a Princeton reverb, so they have a reputation for being a little bit on the wimpy side, mainly because they don't have the extra gain stage that the reverb channels have in the other amplifiers. So basically it's pretty much just like playing through a normal channel on a Fender without the reverb channel. Not really wimpy, just different. But there are a couple things here you can do to actually make this amp sound better. And one of them happens to be with the phase splitter circuit. So let's tear into this. I've actually current limited it already and checked it out. There's actually no major shorts or anything. So let's do some checking here and see what else we've got happening. So, as I say all the time, first thing you want to do when you're working on an amp is pull this fuse. You never know what's in there. And in this case, it's a 4 amp. This is supposed to have a 1 amp fuse in it. So we'll deal with that. Another thing we're going to do is change the power cord. It's got the old 2-prong cord on it. Someone's replaced the end, and just for fun, let's take a look in here. This is hard to do one-handed. Oh yeah. Nice strands of wire hanging everywhere. Yep. Hillbilly DIY. Okay, we're going to change that anyway. Seems like our pilot light's burnt out. Just put in a new GE47 bulb. We're good there. So all the lights are on now. Getting over here to what we were talking about. And we're going to talk about two things here at once. One, the biasing. Right there, 30 mils on that tube. Okay. Get over here to this one. This one's a little tougher to get to. 11. But that sounded great. It's like driving a car with a flat tire. So anyway, that clues you in on some of the issues we've got going on here. So we're going to start tearing into this. First thing, the front panel comes out and gets cleaned up because of corrosion and all that. We want this thing to be grounded properly, so we don't have any oscillations, parasitic oscillations and so on. That front panel is very important. So here we go. I'm going to try to point something out here to you. Of course, it's very hard to see. I have used some Scotch-Brite to clean up this side of this ground panel. This side, you can still see the oxidation and stuff on. Just wanted you to see the difference there. You see the difference in color. I'm also going to be cleaning the back side of it where the pot's ground to it, and the chassis. And I'll probably put a couple solder joints to the chassis just to make sure on the bottom side. Very important, guys. This is where a lot of the oscillation problems come from in fenders. Alright, so let's catch you up here. I have the ground plate back in, have all the pots back in it and the jacks. I've cleaned the jacks at this point. If you look down here, let's see if you can see it. If you look down there, there's a solder joint from the ground plane to the chassis. There's another one over here just to make sure. Scrubbed up these knobs, cleaned up the front panel. Okay. Come over here. I have added the two 100 ohm resistors to ground. And you can see here where I terminated the center tap. I have seen these burn up a lot over the years on fenders to protect things. So this is a really good idea. And you notice I've got the resistors raised above the leads here, so when a resistor fries, it does not burn the leads. So I think that's where we're at this point. Next thing here is to change this power cord. Get it taken care of. Then we have to take a lunch break. Let's take a minute here to clue you in on another one of my sneaky tricks. I've pulled the original cord restraint. You see it's flat in the bottom. Of course the top of it's curved. What I do is I file out the bottom of this to make it round. Then I use one of the IEC replacement cables, a smaller gauge, and cut this off, and it'll fit well through that strain relief. So we've got our AC cable in. You can see our little solder joint here to chassis. This coil is on purpose. Our black and white leads run over here to the appropriate connections on the accessory outlet. This green wire, your ground for your chassis, is longer than all these. That's done on purpose. That way, if the cord is ever yanked out of the amplifier by accident, and you rip this stuff out of here, and one of these AC leads hits the chassis lead stays grounded longer than the rest of them. That's the idea behind this. Now, moving over here, I've got this rat's nest. So anyway, what we're going to do, we're going to completely rewire all this area. Uh, the way they've got it done, they're actually breaking the fuse on one side of the AC and the power switch is on the other side. For safety reasons, we want the fuse before the power switch on the same AC line on the black side. The white will connect directly to the power transformer, and I will be, oh my God, he's going to say it. How could he possibly leave the death cap in? Thousands will die. Well, guys, the true story here is, as long as this works right, it's okay. And if you're playing somewhere else other than in your bedroom, you may actually need this ground switch. I found out years ago, out playing in clubs and bars and everything, that wiring can vary a lot. Having this ground switch can actually save you. What this idea of this capacitor to ground here for your ground switch is, this capacitor is actually connected to one side of the AC or the other connected to ground to bleed off noises on the AC line. It wasn't intentionally put there to shock you. Oh, and by the way, chances are you won't get shocked unless you're barefoot on concrete. Okay, I'm going to rewire all this. I'll be back with the finished product in a minute. So let's show you the new wiring scheme here and why. So our white AC lead comes in here, comes over to this side of the ground switch, and is connected directly to one side of the primary of the power transformer. The black wire comes in here from the AC over to this side of the ground switch, then out of the ground switch to the front side of the fuse holder. Now, okay, this is something very important here too. This is actually one of my tricks. This is so that if the fuse gets stuck in a fuse holder for some reason, yes, I've seen it happen. There's a reason for this. And you go to get a hold of the end of the fuse here to pull it out, and the fuse is still good, it's going to nail you, because your voltage comes in on this side of the fuse holder. So what I do is I move it over to here, so when your cap is off, the AC is disconnected from the fuse. Then you can pull it out without getting shocked at all. Okay? Then the other end of the fuse holder connects over here to the power switch, which then connects to the other side of the primary of the transformer. That's a few little safety things there for you. Yeah, I know. You're all saying, yeah, he's got all this safety stuff he's doing, but he left the death switch attached. I'm going to tell you, I've never been shocked on an amp from a bad ground switch. I've worked on a lot of amps. I've owned a lot of amps. I've played in a lot of CD bars. So, like I say, you got to worry about the wiring in these places. By the way, how many of you guys carry anything in your gig bag to check wall voltages and polarities? Okay, moving on. Well, we have our power supply resistors all replaced. The 1K resistor had drifted quite a bit here, and I always get rid of all the carbon composition ones in the power supply anyway. Usually pretty noisy. We are leaving the original filter cap. The reason for that is this one checks good, it looks fine, and I have had a huge amount of failures with replacements for these. So I am betting that this original cap will probably last longer than one of the replacements. They say it's not humming, it doesn't have any problems right now, it looks good, we're leaving it. I have replaced the bias cap up here and I've tacked in the original bias resistor, which will probably get changed. Chances are pretty good. So we've got a new set of output tubes in it. We've got a set of JJs in it. We're going to fire this up and start checking things, get the bias taken care of. So as expected here, I found exactly what I thought I would. The new tubes are running about 33 milliamps apiece at 430 volts. So we have to cool this down a little bit. So I'm going to be using a variable resistor. We're using a pot across the bias cap to dial in what I want. Okay, we've got everything all hooked up here. A lot of things going on here. It looks like we're all hooked up to life support. We've got leads everywhere. It's like a explosion of spaghetti factory in here. Anyway, a lot of things going on. So, at 15 milliamps per tube, that's what I've got set at right now, just to show you something. Our power supply has dropped to 403 volts. There you go. So your voltage goes down and the amp operates. That's typical. Okay? So we're biased at 15 milliamps apiece right now. Now, I said that's too cold. It is too cold. But let me show you something first thing here before we get into that. I'm actually running my signal directly into the driver for the phase splitter, which would be your phase inverter type section for your amplifier. So I'm coming into pin 7 on the first preamp tube, which is actually the driver for the phase splitter, which is on the next tube for your outputs. So now let's go here and show you why this is too cold. So what I want to show you here is at 15 mils, I want you to notice this little hump right here. This is a crossover notch. What is this? Amplifier is barely running into class AB. I'm running just enough signal into it to keep it from clipping at either top and bottom. And this indicates a crossover problem where the one tube has a timing problem with the other tube of turning on. So it gives us this notch. Now as you push this amp harder, this notch will get worse. Now, this results in what I refer to as a B and a pop can type of sound on top of all the notes. Crossover distortion is not pleasing, it's not musical. The amp will lack punch and bass as well. So let's get this biased up a little bit more. There. See how nice and pretty that is? There's no notches here. I actually have the tube biased up at 22 mils. I noticed that the crossover distortion actually went away at about 17, 18 mils. So we want to go just a little bit more so it doesn't drop out. Like I say, there's a lot of things to do with biasing an amplifier. You can't just pick a random number out of the air because it doesn't match all amps. Plate load values for your tubes are different. Plate current for your tubes are different. And when I say plate load, I mean your output transformer load. Yeah, there's a lot of things to take into consideration here. So just pulling random numbers out of the air doesn't work. And from amp to amp, model to model, let's say, it varies. A Princeton reverb, or Princeton, does not run at the same point that a Deluxe does, even though they have the same tubes in it. They got vastly different output transformers. So your screen current, a lot of things make a lot of difference. Just making a point here. 15, 16 mils on a Princeton or any 6V6 amp, probably too cold. Also here, by the way, my calculations also back this up a little bit. You see how clean our signal is? If we goose it a little bit more, it'll start clipping, but still have any crossover, okay? If we go over here, our power supply has dropped to 390. So if you do the calculations at 390, instead of at idle, the numbers fall right in at 60% of plate dissipation, which is usually kind of where I like to see things. Varies on the amp again and other things. But as it turns out, my numbers told me that this should be running about 20 mils per tube. And I'm running at 22. So after a little creative resistor measuring, matching, and so on, I was able to series 2 resistors to get me exactly the resistance I needed to get my bias. That came out to actually be 28.5K resistance, not a standard value. So I sorted around and found a 22K and a 6.8K, and I sorted through them and found the values that when I put them together actually matched, because, you know, tolerances and all that. So, okay, moving on to the second issue here. Let's talk about the phase splitter circuit. In theory, if you have the same resistance for your plate load resistor as you have for your cathode resistor on a triode, and you apply a signal to it, you come out with even signals out of phase on a plate and cathode. Well, in theory that works really well, but the problem is you have to have another resistor here as a voltage divider for a bias stick to make the tube work. So what you have is a 56K resistor here and a 1K resistor here. That's on your cathode. On your plate, you have a 56K down here. Now, depending on the values, again, tolerances and all that, it could be off quite a bit. I'm measuring this amp right now, and I got 3 volts difference in drive, an AC signal, from side to side, which makes one side clip faster. A lot of guys like that, but, you know, it actually makes the amp sound a little weak, and bass response is off a little bit low. So we're going to fix that too. The solution, simply match resistors. I'm going to replace this resistor anyway, so we'll use a high quality resistor there and here for the plate and cathode. I'm going to actually match. When I take this 56K and this 1K, I'm going to match the resistances and actually probably add a 1K to this one, so that the resistance is the same. And now our phase inverter is balanced. We have 22 volts there. We have 22 volts there. And when you look at the signal on the scope, it looks like that. It's not clipped off on one side anymore. It's even. Okay, that takes care of all that. Now, we'll get in here, we're going to change a few more capacitors, a few more resistors, clean some tube sockets, clean some pots, and we're going to be done. Well, we replaced a few plate load resistors, some cathode resistors, some cathode bypass caps, cleaned the pots, tube sockets, checked it out here. I believe this is ready to go. Now we've got to turn our attention to the cabinet, which is another whole issue. Alright, well, I've just checked it out. Checked the old tubes, make sure that our gain, everything's fine. Everything's good. So I'm ready to start on the cabinet. I just measured 17 watts clean coming out of this amplifier. So balancing that phase inverter helped a lot. Now that we have the amplifier finished, we can turn our attention to the cabinet, which at first glance doesn't look too bad, but it's got a few issues. This has actually been a work in progress for a couple weeks here, and you'll see why. So those of you that are astute may have noticed that the speaker opening in this is quite large. So to show you what's going on here. This is actually one of the few Princetons that left the factory with the 12-inch speaker in it. So yes, all this is factory. Originally we'd planned on changing the baffle because he wants to put a 10 back in it because he's a harmonica player and he wants a 10. So we took out the replacement speaker somebody put in it years ago, which is an old Alnico CTS. It's been brutalized, patched, mangled, you know, all that. Anyway, so my solution was to make a baffle ring. So what I'm going to do is mount this on the original speaker bolts and then mount a period correct gold label Jensen. Of course, you know, he bought this speaker and it was old too, so it had to be reconed, so I used one of my last new old stock cones. So we'll get it put in here. Also, he had a back panel missing, so I made him a back panel. Over the years I've acquired a lot of patterns for these because I get a lot of fenders in here missing back panels. So anyway, we're going to take this cabinet back here and give it a good dousing with 409 and scrubbing with the scrub brush, and we're going to get it cleaned up and get ready to start finishing this up. So scrub-a-dub-dub. Speakers mounted and wired, cabinets all been cleaned. Let's stick the amp in it. Great. Another insult here. A broken off back panel screw. That one caught me by surprise, but you know how we deal with that. Yep, that's how we deal with that. So, dowel plug and some glue. And some Tolux glue. Great. Another broken off one here. I didn't see that when I was cleaning it up. Okay. Well, we have the amp finished. I've been checking it out here a little bit. Since I've been getting a lot of grief about not doing sound clips, one person actually mentioned to me that, well, if you, without a sound clip, we have to take your word for it, you fixed the amplifier. We don't know that it's loud and strong. I thought, well, you know, with all the amps and guitars I do for a living, for a lot of years, I never thought that anyone would question that I didn't actually fix something that I had in a video. So anyway, so for you guys that insist, okay, fine. And for a little wiggle for your giggle, we have the Tremolo. And when I mentioned this to the fellow that he needed a foot switch and I was going to order him one, I told him, I said, I would probably have to fix your foot switch when I get it. And as usual, Fender didn't disappoint me. So, guys, man. Anyway, here we go, Tremolo. So I hope you can get past the sound clips and actually see the importance of what was in the video. So until next time, play nice.